So it's still simulating, but this is where we're at so far. I mean, this is a crazy result. It's not wrong, but it's just so fragile. It's a lot of stuff's being destroyed. And we do see things kind of staying together up here a little bit, but the point is we're going to need to make the glue stronger for some of these things. In particular, those internal constraints are just probably too weak. So I'm going to say you can play with those. You can increase them by orders of 10. I'm going to do another order of 100 here just to see, because that was so weak that I think I can jump up 2 orders of magnitude here. Click reset simulation just to make sure that it, sucked in the new constraints and all that kind of stuff. We're going to wedge these numbers later on to just find the right one, but I just wanted to get in the ballpark at least. So let's see what this gets us. So this is still going too, but you can see it's much more solid now. It's still not maybe perfect, but it's definitely more solid. We can see how it stays in one actual full chunk as it comes down and then starts to break apart, especially these walls on the left side here are starting to look cooler. That's what we want. We want to see more structure. We want things to kind of stay together a little bit more than that. We don't want it to be so fragile. So we're getting there. Again, we'll wedge some parameters later to get to a final result. That's fine for now. Now, here's our cache that we can scrub through. I'm going to click this brain here to disable any kind of auto resimming. I just want to look at this cache for a minute without losing it by accident. If we come into our constraint network, you'll notice constraint network never actually moves, which is fine for us in our case because we read in our metaball when the building is still in this original position. But what if you did want to have multiple explosions and the explosions need to affect where the constraints are now as the sim is going on? This is another good reason to do this separate stream here. What you can do is we can read in the actual geometry, the actual pieces from our sim by putting an object merge in and saying ... /... which means get me the path that is the node above me, ... /... is the node above that. So the DOP network. So the DOP network, then put a colon, and let's do RBD packed object 1/geometry. And if we look at that, there it is. There's the actual sim. So what is that? Like, why is it this crazy thing? What's this colon about in particular? What it's saying is, in the simulation, and here I am in my geometry spreadsheet, in the simulation, even the geometry spreadsheet looks different. There are literal nodes, like the DOP network node itself. Things like this, the RBD packed object, this generates a quote-unquote dynamics object. So the pieces and all that stuff are stored in the quote-unquote dynamics object that this generates. That's why this says object name, and it has the same name. Remember that op string from before? It creates a thing. It's not a node. It's kind of just an ethereal thing. It's an idea that's floating around in here, and there it is. RBD packed object. This could create multiple ones of those, but we have it just create one on the first frame. So the point is, this node exists not as a node, not as a thing with a hard and fast path to, but as if you think about object-oriented programming perhaps, if you have that kind of background, this is an object that was created in memory that then has subdata, things like geometry, which looks like the normal geometry spreadsheet we're used to, where we see velocities and we see positions and colors and stuff of that nature. So this is data that's stored inside of this thing, and this thing was generated by this. So to put that all together, this is saying in that simulation, there is, or there should be anyway, a dynamics object named this. And inside of that, there should be geometry subdata. So I know that's a little weird, but that's the idea, is that we're not looking for a path to a specific node. We're looking to a path to a simulation and then a dynamics object that was generated inside of it. That's what the colon means. And then it has its own subdata here. So now that we have it, what this essentially is a bunch of points with names on them. And we have these points that also have the original names. So we can move these based on this. So I'm going to say transform pieces, transform them to where these are. So it looks crazy, but it's not really not. Remember that the broken group that we're working on here doesn't delete these primitives. It just says they don't function anymore. So that's what we're seeing. All this stuff that's flying out like that, really these primitives aren't working anymore. That's why they're stretching. If you wanted to be even more clear, we could just say, like, we could delete the broken ones, just to say, and you can see now, this probably makes more sense, where we can see the constraints disappearing. Again, that propagation rate kind of stuff. Awesome. Something like that. The point of all this was to say that when we do this kind of stuff, where we read the metabol in and we're looking to see which constraints should be broken, they really should be in the simulation space when we're checking for them. It won't really matter for us because we're only doing the one explosion before it moves. But it's very possible that you're trying to do this to a moving object in your scene, in your own work. And I just want to get ahead of that question. How do you account for that movement? And that's how you do it. So we have that in there, and there you go.